I'll quickly introduce myself. So I'm James, and I'm a dev advocate at Couchbase. We have a booth down there in case you didn't see us. And Geoffrey is a startupper. He's doing a project that's quite exciting around Wi-Fi direct and peer-to-peer and distributed system and things like that. So we're going to talk about different things and for about 15 minutes, and then afterwards we'll open it up for discussion, and we'll like to know what you guys think, how you handle the situations that we'll talk about, and then evolve the discussion from there. Sounds good? Yeah. Okay. So yeah, go ahead.
There's different way to handle disconnection problem doing by yourself, meaning a combination of API and local storage, cache. I don't know what you are using, or using Firebase parse commercial solution, and but those kind of solutions are more working with a connection, offering unconnected, I don't know, placebo, a solution when you are disconnected, but they are mainly used in connected mode. That's the main difference.
Firebase and parse, there's certainly an offline mode, and I'm sure some of you are using them, and they're awesome. But it's not sort of like a truly offline mode, as in how long are you going to be offline for? Is it just for a month, or could it be longer than that? And so this is kind of a difference between those backends as a service and then other distributed systems.
Who is using parse of Firebase here? Just a few, yes. And there is some totally disconnected solution, like Dropbox. They have a very small API, and you can have some synchronization with a folder. And there is, you can use Git. It's good synchronization system. Or you can use Couchbase, which is, in my knowledge, is the only database who offer a synchronization system. The main advantage is that it simplifies your architecture, because when you have a click on the UI, you have to go through all the layers, going through networks one way, then the other way back. And if you have a failure on every step, you have to handle it on the UI, explaining what the reason of the failure. It may be, so you see there is here just 4 potential failure, and this can be avoided with another architecture that James wanna present.
Say it in French. So, I mean, okay, yeah. So, the main difference here is if you switch to an embedded database, that could be really any database. It doesn't have to be Couchbase Lite. It can be SQLite or Realm or any other database. You do your reads and your writes to your database, and that then has to sync to your cloud. And what happens is you would maybe have 2 different code paths in your class or your controllers or your presenters or wherever you do it, and it would be fetching it from the database or fetching it from the network. The difference here is that there's another set of APIs that are in the Couchbase Lite framework that take care of replicating the documents from the Couchbase Lite database to the server, and then vice versa from the server to Couchbase Lite. So in your code, you're always just writing and reading from the database, and then the database is picking this up internally.
Handling error network error is a pain, and as a user, I'm very interested in using a product like Couchbase, handle the sync and the sync errors for me, meaning I just focus on my business to write and read on a database, which doesn't go down.
Yeah, so you don't have to check constantly for network availability. And ironically, the title of this talk was "Don't be afraid to check for network state." Well, in many cases, actually, you can not be afraid by using something that does it for you. In other words. Here I go over this very quickly, but basically, if you're using a distributed database, the language that you use to replicate documents between nodes in a system has to be sort of understood from each side. So in this case, SYN-Gateway, which is a Golang server stateless, is receiving everything and then storing that into Couchbase server. And that's how the stack is divided, and every component is open source on GitHub, and you can use it, obviously, on your own. You have to sort of set up deployment pipeline on your own. So that's a big difference as well with no backends as a service, where you have to instead just sign up and you get a backend. In this case, you have to spin it up on a VM of yourself and do the deployment. But this is basically what it's doing. It's taking care of all the data syncing and sharing. And there's a scenario which we didn't talk about here, which is also peer-to-peer. Since the Couchbase Lite database is able to persist and then replicate to the server, well, if we had the ability to add the listening functionality that SYN-Gateway has to Couchbase Lite, we could then replicate between two Couchbase Lite databases. And that's what we did. We built another component that you declare in your Gradle file called the Couchbase Lite Listener. And then what it does, it adds an HTTP over the database that could then be sort of a target of a replication or a source if you're pulling from it. Does that make sense, or are there any questions on sort of this architecture? And how you could have distributed database on mobile as well as on server. Okay.
The reason you could be interested in those peer-to-peer scenario is, for example, IoT or professional solution in, for example, plants where you don't have Wi-Fi, and so you're using peer-to-peer is the only way to go for the data to go back to the people responsible, yeah, hopping from one node to another.
Yeah, that's right. So you could even have a chain, and I mean, what you're doing is that basically you have a mesh network and you have to determine who's the lead, and then everybody syncs to.
Yes, it's mesh. Mesh is usually finding a way from one terminal to another. For example, if A just can see B and B see A and C, data will be are going from A to C through B, and with data replication like this, A sync with B, and then B sync to C, and with the data from A. The difference is that you don't have to have A, B, and C and on the same group at one time. You can have one and B, then 2 hours later B and C syncing, and A and C will never been on the same network called etching data.
Yeah, and actually that ties really well into the next slide, because when you have a distributed database, you have to think differently to your sort of client, which is the slave, and the server, which is the master, which is how it works in most cases. And if you take a server database, the reads would come from the slaves, and then all the writes would go to the master, and then the master would update the slaves. But if you're truly distributed, it adds a lot of complexity in between the nodes, because if a write can go to any node, you have to make sure that the other nodes have the write, so that when you do an update on the document, you're actually able to do it, and the system knows about it. Or if you do a delete, it knows about the document you're trying to delete. And because there's this time latency on devices. You know, somebody's online, somebody's offline, they're both offline, they're both trying to make a write, so there's no synchronizing between those two databases. What can happen is to have conflicts. And let's take an example here where two users are on the same timeline and they're doing operations each on their database. So one is on the top, imagine, and the other is below. And in this case, the user one is reading V0 like a document, a state, and it's updating it, and it's calling it V1. And user 2 then is reading V0, sorry, that's actually confusing. That shouldn't be there. So it's writing V1, and then this one is reading V1 because it had time to synchronize, and then it's writing V2, for example. Whereas in this case, so it's like transitioning. They're sort of both doing it at the same time. And because user 2 is reading V0 and writing on top of that before it had time to write the update, which is V1-1, what's going to happen is there's a conflict because they're both offline, and the system is going to acknowledge this because they're both sort of children of their closer parents. You can think about it like a git commit on Git. And that's how it would look like instead. So they're both pointing to V0. That's something you can fix it in different ways. There are different theories in distributed systems to fix that. But one of them is to just let it. So the way we do it is that we just tell you there's a conflict, and it's your job to resolve it. And otherwise, all nodes in the system will sort of default to one of them, depending on a deterministic algorithm that I won't go into.
And this is so the peer-to-peer replication enable new scenarios, but it brings this problem. The simplest way and the most robust way to handle it is to never update, to have a data model without update, or to have update with responsibilities. It means that just the creator of the document can update it or something like that, but it's just to have no update at all. It's the simplest way, and to think your data as an event store.
So show of hands who does not update in their app. Right, so in most cases are obviously the update, and you just have to think about your documents as being as small as possible so that they don't clash, and have keys that reference one document to the other, similarly to foreign keys and things like that.
This is just a bit of code to show that thinking with Couchbase is pretty simple. Just this.
Can you actually see it? All right.
Okay.
Looks pretty terrible. Let me just switch to. So while I don't know why. Yeah, Android's German actually. While I show you that, well, it's already. I can quickly show you a demo, right? So let's say that here I've got a QR code, and oops, sorry, I'm taking out my cable. Right, so that QR code is encoding the URL of the listener, the optional package, right, that exposes the database via REST. And the Android app is going to send a picture. So I'm going to take a picture of the crowd. Okay, and now I click done. And now I'm going to scan that QR code. and now the pictures are replicated. So let's take a look at what happens here. Let's turn here.
In this scenario, the QR code is a DNS service, kind of.
Yeah, in that case, the QR code is acting as the mechanism that makes each device know the IP of the other. So in that case, it's running on, the iOS simulator is running on the port 55,000, and I can see if I go to, for example, all DBs, that it's got one, it's called DB. So I go to DB and I look for all docs, and I see 2 documents because I sent 2 pictures, and I want to include the docs, sort of get the content out of them, and I get stuff like attachments, and that gives me the information about the attachment. So the attachment is called photo, and the ID of that attachment is this one. And then if I look for it, the browser's downloading it by default because that's what happens because of a header, but basically then the picture is there. So it's just HTTP, and you could be using NSD instead of QR codes to do the peer-to-peer discovery. You could also be using Wi-Fi Direct on Android. That's what you're using.
Actually, it's also DNS service. It's a kind of DNS service, even in Bluetooth.
But you don't have to be on the same internal network to discover the other peer. That's the difference with Wi-Fi Direct, isn't it? It can just be 2 devices. I guess, yeah, 10 minutes to go, so let's just open it up for questions. Like, people using Firebase advocate for Firebase. We want to have a good debate here.
Who care about going offline? Okay. What are you using?
Hi, I'm using Couchbase to synchronize conversation between application.
Using, sorry?
Couchbase.
Oh, you're using Couchbase?
Yeah.
Okay, great. Come on stage. And in your case, you're going everything via the server, right? Or is there peer-to-peer as well?
Yes.
Yeah.
Applications are not talking together. They're talking to the server.
And what server are you using on the back end?
I don't know.
Oh.
I just developed the application. I'm client of server.
Well, we can talk about peer-to-peer connection, but if
I think the most general use case is not peer-to-peer, right? I know you love it, but we spoke a lot about peer-to-peer in the talk. So I'm keen to know how how you would see this. It's hard to ask because I don't sort of write Android code on a daily basis. So it's hard for me to feel the pain that you go through, and so I'm imagining that it's all rainbows. Since there are
what do you do when you have no network if you don't handle it? Oh.
Who displays a pop-up to say?
Serious?
Yeah, but I mean that's the first thing you do, right? Like if you don't have enough time, or you use Couchbase.
In my case, working for a business, it was not a. I never done for a general public application. It was only for business, and it was. I could not say, okay, no network, no working. It wasn't possible.
That's like the sort of black on white background. So you can is it better now? Yeah. Okay. So imagine the sync URL is just a string. It's your server running on the cloud, and you've instantiated a database. So like the /db that we looked for when we did the REST call in Chrome. Instead, you're just using the native API here, and that database, you tell it to create a pull replication from the sync URL database. That's going to pull, and then the push similarly is going to push the content of the local, and then you start the replication. And that sync URL could equally be that code. That start CBL, and if instead you pass in a string, you could use it to push and pull from a device or to a device, and then the same push and pull to a server. So the code is very similar, regardless of what you're using. The database doesn't know if you're syncing to the cloud or to a remote Couchbase Lite. Yeah.
Which side handles the conflict?
Which one?
Which side handles the conflict?
Can you repeat the question on the micro?
Sorry, the question was which side resolves the conflicts. And basically, like I showed, when you have like v1-1 and then v1-2 sort of merging into v0, that's how it's going to be. And Couchbase Lite, Sync Gateway, other like instances like PouchDB is the implementation running in the browser in JavaScript. They will all pick the same one. So let's imagine they all pick v1-2, and it turns out that you actually wanted v1-1. In the database, you still have both, and you have a call, like you have a document type, and on that document type, there's a method called getConflictingRevisions, because every sort of time you update, you create a revisions, similarly to a commit. And what you tell the database is document.getConflictingRevisions, it returns 2, and then now you have your logic to say, oh, I want the other one because the updated time is like later, or I want to do a merge between the two, or I want to display them to the user, and the user picks the winner. And then you resolve it by either saying, yes, this is the one, or this is the merge, and I delete the two others, or this is the other one. But yeah, it's definitely difficult, and the good thing is that it will be consistent if you don't handle it, and then when it comes time for you to handle it, you can add the code.
A stupid rule is you can just, on the mobile, put a rule, if there is a conflict between a data coming from server, a modification coming from server, and one from the user, you give the user right, so you override with user one. Question?
I guess we're done. Thank you very much, everyone.